everyone, very good evening to all the students here who are having their PU2 unit test for chemistry. So we have already conducted a live session before and there were certain students whose exams are still there. So for them again we are planning and I will be discussing the most important questions, the most important numericals that you must practice before the exam, and also I'll be telling you what all things you should revise in the last minute so that even if you haven't studied anything, if you revise these topics you will get a decent mark in the unit test. Okay, so hello Akshata. Yes, so students, if you have the exam then please let me know, and if you have already attempted the exam then how was your exam, that also you can let me know. Okay, so good evening Neon. So hi, good evening. How Neon, is your exam over or do you have the exam? So do let me know. Yeah, so we can wait for some time for some students to join, then we will be starting. Okay, so everyone, mood, yes, okay mood, I will be taking this. Okay, the last MCQ session chemistry PDF, we will upload it today in the WhatsApp channel. Okay, I think it should be done, but okay, we'll be discussing and I'll be uploading it. Okay, don't worry. And we have so many students here, so a very good evening to everyone. Yes, so can we start? Okay Neon, so that is very good. Okay, so can we start now with the session? Okay, just a minute. Okay, so let's start. So in the unit test 1 syllabus, we have 3 chapters, right? One from physical, one from inorganic and one from organic. So solutions, D and F block elements and haloalkanes and haloarenes. So some of the questions I have taken from the last session also, and some new questions are also introduced. So do practice because these are the most important questions. The more times we revise them, the better we will remember. Okay, so let's start with the first question. An ideal solution is formed when its compound have no volume change on mixing, have no enthalpy change on mixing, have both the above characteristics, have high solubility. So those who know the answer, quickly comment and tell me what will be the answer for this question. Yes, which option you think? Please mention the question number and the answer. Okay, with the question number you have to mention. Okay, so let me see. Yes, hi Naveen, hi Giriraj. So yes students, if you have exam tomorrow, do let me know. Giriraj has given the correct answer, so very good dear. So you know that for ideal solution we have two concepts, that is delta V mix is equal to 0 and delta H mix will be equal to 0. So what will be the correct answer? That is both of them have the above characteristics, option number C here. Okay, yes everyone. Next question number 2, if molality of the dilute solution is doubled, then the value of the molar depression constant Kf will be. Okay, so here we have option halved, tripled, unchanged or doubled. So can you guess this answer? Those who have attempted my previous session, they should be able to answer because I have given answer for this question in the last session. And Khushi is saying even alcohol, phenols and ethers is there, ma'am. Okay Khushi, do not worry, you can revise that. We have one shots for that. In if you can just search in our channel, you will get the important questions from this chapter also. We have done it before, you can watch that. Okay, 2C unchanged, yes, absolutely correct. So remember, this is a constant value. Okay, constant value means it doesn't depend on anything, it is a constant value, it does not change with the molality. So here the correct answer is option number C. I want everyone to participate here. All the students should answer. Please, everybody should answer whether you know or not. Please attempt the questions. Third one, during osmosis, the flow of water through a semi-permeable membrane is from solution having lower concentration only, from solution having higher concentration only, from both the sides of the semi-permeable membrane with equal flow rates, and from both the sides of the semi-permeable membrane with unequal rates. Yes, what will be the answer for this question, dear children? Yes, we have so many students live now. Yes Giriraj, definitely we will make very soon a video on the topic that you have requested. Okay, Yes. So here what will be the answer? Puneet has said A. That is absolutely correct here. That is from a solution having lower concentration only. So if you remember, osmosis we have like this, and one side we have many solute particles, and on the other sides we have less solute particles. Okay. So what will happen? This is your SPM, semi-permeable membrane. So the solvent particles move from here to here, right? So from lower concentration to higher concentration. So that is why option number A. Yes. 3 is A. Mood 3 is A. It is not C. Okay. Next, question number 4. Pure water can be obtained from sea water by centrifugation, plasmolysis, reverse osmosis, or sedimentation. Again, very simple question. Please try to answer. This is also very simple question, direct question. Yes. Fourth one is C, absolutely correct. Reverse osmosis is the correct answer. Let's move to the next question, fifth one. From the colligative properties of solution, which one is the best method for the determination of molecular weight of proteins and polymers? Is it osmotic pressure, lowering in vapor pressure, lowering in freezing point, or elevation in boiling point? So which one do you think is the correct answer here? Naveen, Abhishek, I want everyone to answer with a question number. Okay, please mention the question number and then put the answer so that I can know which one you are answering. So if you are answering this one, fifth one, A is absolutely correct, osmotic pressure. So we know what is the reason. Here a 3-marker question can also be asked, or 2-marker question can be asked. Why osmotic pressure is the best method? So the answer for that, you should be, first thing is it uses molarity. Okay. Second, it can be calculated at normal temperature. Okay, at room temperature we can calculate this value. And the third one, that is the reason here, is that the osmotic pressure, the value is very high value. Okay, fine. Now let's go to question number 6. Yes, Neon, very good, you have given correct answer. Question number 6 here, this is important question. The relationship between the osmotic pressure at 273 Kelvin when 10 gram of glucose, 10 gram of urea and 10 gram of sucrose are dissolved in 250 ml of water is P2 greater than P1 greater than P3, P2 greater than P3 greater than P1, P1, P2, P3, P3, P1, P2. So please think about this question for a minute and then you can answer. Okay, please take some time. This is very, very tricky question. Okay, this is going to be a tricky question. So take some time and then answer. Okay. 6, I have already got answer C. Let's see. What is pi formula? C into R into T. What is C value? I can say given mass by molar mass into 1000, right? By volume into R into T. Right? So now I can say that all of them are 10 grams. So this is fixed and this is also 250 ml of water. This is also fixed. R is fixed, T is also fixed. Now if the M value is high, then pi value will be less and vice versa. So if you see for the first one, that is glucose. For the first one it is 180. For the second one it is 60. And then we have 342. Sucrose mass is 342. So if you see the 61, the urea mass is the least one, and that is why here the osmotic pressure will be highest. So P2 will be highest. So I can eliminate these two options. Okay. Next, this one is 342, the highest value. So the pi value will be least here. So P3 will be least here, and here I can eliminate this one. So option number A. Anybody has given option number A? Yes. Okay, Abhishek is saying, ma'am, tomorrow is my chemistry test, so you have given the important questions PDF. I will study it now and see the lecture PDF once tomorrow morning. Yes, definitely, dear, you can do that. Yes, mood 6A is correct. And Abhishek, all the very best for the tomorrow's exam, and do let me know how was your exam after it. Okay, let's move to the 7th question. The blood cells retain their normal shape in the solution, which are hypotonic to blood, isotonic to blood, hypertonic to blood, equinormal to blood. Yes, what will be the answer here? Yes, 6A I have got. Now 7th one, 7th A, no mood, no. Yes, please check the answer. It should be normal shape means it should be isotonic. Okay, when the osmotic pressure is same, then it will remain in the normal shape. So it is option number B here. Okay, no, those are saying A, it is wrong, it is B. Okay, let's move to the next question. Yes, I have got a correct answer from few students. Let's move to 8th one. Now, of the following 0.1 m aqueous solution, which one will exist the largest freezing point depression? You have to find which one will have largest delta TF value. Okay, so now you see in this question the Kf value will be constant. You just need to find this I and M value for all the options. For option number 1, there are 2 ions, right? So what is the I value here? I value is 2 and the molality value is 0.1. So I will get 0.2. Next, for option number B, if I talk here the I value is 1 and this is 0.1. So I will get 0.1. For option number C, I will get 3 plus 2, total 5 into 0.1, that is again 0.5. Next, option number D, I will have 3 into 0.1, that is equal to 0.3. So which one will have the largest delta TF value? Largest delta TF value, that will be with this one, that is option number C. So 8 will be C. Yes, Neon and Mood has given correct. Yes, so Madara has told ma'am, say thank you to Math sir because we have got the same question. So definitely definitely I'll convey your thanks to Ankit sir. Okay, thank you so much. Yes, fine. Now let's go to Samita. Samita has given the correct answer here and other students have also given. Let's move to 9th question here. Okay, so an aqueous solution of 1 mole in Ki, which change will cause the vapor pressure of the solution to increase. Okay, so what will happen if you add these following substances? That the vapor pressure of the solution will increase. Okay, so that you have to think. We have addition of NaCl, addition of Na2SO4, addition of 1 molal Ki and addition of water. So this is a very simple question. And remember, whenever you add any solute, okay, whenever you add any solute, the vapor pressure decreases. Okay, so I cannot have these things because here I am adding solute, so the vapor pressure will decrease. But here, when you add water, it is also volatile. So in that case, this one will also evaporate, the original solvent will also evaporate and the vapor pressure will decrease. So that is option number D here. Okay, yes. Next, moving to question number 10, that is which of the following salts has the same value of Van 't Hoff factor as that of K3FeCN6. Okay, Na2SO4, AlNO3 whole 3, Al2SO4 whole 3 and NaCl. In which of the following the Van 't Hoff factors will remain same? Okay, so let's see what is the Van 't Hoff factor here. So K3FeCN6, K3 will give you 3 K plus ions and FeCN6 will give you 1 ion. It is a complex, right? So total here number of ions will be 4. Now in which of the other options given here the number of ions will be 4, that you have to check. So in option number A you will get 2 Na and 1 SO4. So A will have 3 ions. Next, if I see B, you will have nitrate 3 ions and aluminium 4 ions. Next we have here aluminium 2 and sulfate 3, so that will be 5. And D we will have NaCl, that is 2. So we have 4 that is matching with option number B. So we will have B here. How many of you have answered correctly? Yes, Puneet and Neon has given me correct answer for the question. Very good, dear. Now let's move to the next question. Question number 11. At 25 degrees Celsius, the highest osmotic pressure is exhibited by 0.1 m solution of highest osmotic pressure. Which one will give you? So we have this formula, pi equal to I into C into R into T. Right? So if I value will be higher because concentration is same for everyone, this is 0.1. Next, if I value will be higher, pi value will also be higher. For option number A, it is glucose, so I value is 1. For option number B, it is urea, so I value is 1. For option number C, it is 2 plus 1, I value is 3. And for option number D, it is I value is 2. Right? So which is having highest I value? Option number C. So that is why we will get CaCl2 as the correct answer. Yes, 11C, those who are saying Nagama and Neon, both of you are correct. Let's move to 12th question now. Which of the following aqueous solution has minimum freezing point? Okay, minimum freezing point. Very, very important question. You have 0.01 m NaCl, 0.005 m C2H5OH, 0.005 m MgI2 and 0.005 m MgSO4. Okay, now if you see here, what is just delta TF is equal to I into Kf into m. This is a very tricky question as well. Now see, the depression in freezing point we get in the form of I into m, right? I into m. Now where the depression in the freezing point is maximum, there the freezing point will be minimum. Means, for example, see, we have a solvent like this. Okay, we have a solvent. Now when you add a solute, the freezing point decreases, right? So the one where the depression in freezing point is maximum, this is delta TF. Okay, that solution will have the least freezing point, right? So wherever the depression, wherever delta TF is highest, okay, there the freezing point is minimum. Okay, so like that we can find out for all the options. Now let's do it quickly. If you have already done, you can put down the answers in the comment section, or else just check your answers with me. So with option number 1, what is the value of I into m? I value is 2 because NaCl will give you 2 ions and concentration is 0.01. So I have 2 into 0.01, that is 0.02. Next we have option number B, 0.005. Okay, and we have only there is this ion will not dissociate. Okay, C2H5OH is only one single compound. So here I have I value is 0.005. Next, if I see option number C, that is 0.005 into 3, 0.005 into 3. So that will give me 0.015. Okay. Next, option number D, if you see Mg2SO4, 0.005 into 2. So that will give me 0.010. Okay, so now you see where this value is highest. The value of Im is highest in which case? I can say it is highest in 0.02, right? So we will have the maximum depression in this one, and the minimum freezing point or the solution freezing point will be the least in the option number 1, that is you have 0.01 m NaCl. Okay, yes, Karthikeyan, you are absolutely correct. Delta T Im is highest for option number A, so that is why that solution will have the minimum freezing point. There the depression is maximum, so that solution will have the minimum freezing point. If the question would have asked which is having the maximum freezing point, then where the depression is least, right? The depression is least in this one, so this one will have the minimum freezing point. Clear everyone? Is this question clear to everyone? Yes, just put a thumbs up if it is clear. Okay. Yes. Hi Austin. Hi. Very good evening. How are you doing, dear? Okay. Let's move to next question number 13. For 0.1 m solution, the colligative property will follow the order. Okay. So colligative property will follow the order. So if you know, colligative property will be proportional to I value. So just calculate the I value. You have NaCl, Na2SO4 and Na3PO4. Where the I value will be maximum, there the colligative property will also have a maximum value. So we have Na3PO4, Na2SO4 and NaCl. So for NaCl, the I value is 2. For Na2SO4, you have 2 sodium and 1 sulfate, I value is 3. For Na3PO4, you have 3 sodium and 1 phosphate, that is 4. So I can say the I value is maximum for Na3PO4, okay. Okay, then least is for NaCl, and then medium is for Na2SO4, and the highest is for Na3PO4. So that is option number B. Yes. So I have neon and mood for correct option. So that is option number B is correct. So here we have got the correct answer. Next we'll move to question number 14. So here it is a statement based question. Okay, two statements are given and you have to find out which is the correct statement based on the options. Okay, so the statement 1 here given is, if red blood cells were removed from the body and placed in pure water, pressure inside the cell increases. Okay, and statement 2 is, the concentration of the salt content in the cell increases. So this is also very tricky question. Just think what will be the answer here. Yes, can we think about the answer here? 14A, Mood has already given the answer, both has correct, Karthikeyan has given the answer. Okay, let me tell you, okay, if the red blood cells were removed from the body and placed in a pure water. Now see, you have a red blood cell here. Here some concentration will be there. Now this is pure water. So what will happen? Water will flow inside. Okay, water will flow inside this one, as a result of which, the placed in pure water, the pressure inside the cell will increase. So this cell inside this, the pressure will increase. So statement 1 is correct. Now talking about statement 2, the concentration of the salt content in the cell increases. Concentration of the salt content in the cell increases. Now see, what is concentration? Number of moles by volume. Now when extra water has increased inside, when extra water has entered inside the cell, the volume of the cell has increased, right? If the volume has increased, the concentration will decrease. So what I can say, the concentration has decreased but the pressure has increased. So statement 2 is wrong, statement 1 is correct. So I can say that statement 1 is correct but statement 2 is incorrect. So that is option number C here. Okay. Yes, now please tell me, students, you have given wrong answer for this question. Just see and tell me now, is it clear to all of you? If it is clear, we'll go to the next question, or else I can explain once again. Okay, students, now bring your calculator and come and sit, because now we will be doing 3 numerical questions. Okay, so be ready with your calculators and pen and paper. Okay, 14B, is this clear? 14 answer will be C. Is it clear to everyone? Please let me know in the comment section quickly if this is clear or not, or else I will explain once again. Yes, Nagamma has given, Mood has given me the green signal to move to the next question. So yes, we'll move to the next question here. Yes, okay. Let's move to 15th question. During depression of freezing point in a solution, the following are in equilibrium. So you have, remember the graph, what happens? You have a solid, this is liquid solvent, and we have solid solvent. Okay, when these two meet, that point is your freezing point. Sorry, this side, that point is your freezing point. This is vapor pressure, right? When the vapor pressure of the liquid solvent and the vapor pressure of the solid solvent is equal, at that time we get freezing point. So at that time, which two things are in equilibrium? There is nothing about solute. Okay, so all the options where solute is there, you can delete them. So it is liquid solvent and solid solvent, that is option number A. Okay, yes. Okay, okay, Anita has told to explain once. Okay, so Anita, I think you are saying for question number 14, I'll explain it once again. By that time, other students, be ready with your calculators, pen and paper. We'll solve 3 numerical questions. Okay, so now Anita, see here. See, when you have a red blood cell, okay, it will have certain components in this, so it is concentrated. Now when you put it in pure water, so what will happen? Osmosis will happen and pure water will come inside. Right? So the pressure inside the cell will increase. Clear? Now when we talk about the concentration, concentration formula is what? Number of moles by volume. So when water molecules have gone inside, the volume of the solution has increased. Now if the volume has increased, concentration will decrease, inversely proportional. So if the concentration decreases, then what we can say, here it is given increases. So that is why it is a wrong statement. Okay? Yes. 15th A is correct. Now we will go to numerical question. So please solve the question, see the question, write down the formula and quickly solve it. Okay. It's a numerical question here, that is 450 centimeter cube of an aqueous solution of a protein contains 1 gram of the protein. The osmotic pressure of such a solution at 310 Kelvin is found to be 3.1 into 10 to the power of minus 4 bar. Calculate the molar mass of the protein. R value is given. This is a previous year question. Now students, from colligative property numerical questions will definitely come. There is no doubt in that. So you need to prepare basically these, the freezing point, boiling point and the osmotic pressure questions. Okay, so this is a question from osmotic pressure. Try solving that quickly and I will also solve, and let's see who does it faster. Okay, fine. So what is the formula? Data given to me, 450 centimeter cube of an aqueous solution. So I can say volume is equal to 450 centimeter cube or 450 ml, right? Because 1 centimeter cube is equal to 1 ml. Next we have 1 gram of protein. So what is the mass here? Mass is 1 gram of protein. Okay. The osmotic pressure of such a solution at 310 Kelvin. So what is temperature given? 310 Kelvin is found to be. So what is the pressure? This value is 3.1 into 10 to the power of minus 4 bar. Okay. Calculate the molar mass of the protein. So let's use the formula. We have pi is equal to C into R into T. C is what? Given mass by molar mass, molarity, right, into 1000 by volume into R into T is equal to pi. Now let's substitute all the values. What is pi value here? 3.1 into 10 to the power of minus 4. Okay, WB is 1 gram, molar mass we have to calculate, okay, into 1000 by volume is 450, okay, R value is 0.083 and temperature is 310. Now just solve this, take MB that side, divide this one. So what I will get, if I just write the correct value, I will get MB equal to 1000 into 0.083 into 310, okay, divided by 450 into 3.1 into 10 to the power of minus 4. Now if I solve this, what are we getting? So I can see all of you can just quickly calculate and tell me the answer. Yes. Yes, so if I solve this, you will get around 1,84,444 gram per mole. Okay. Yes, Neon has given me approximate answer. Neon, you can check the calculation. There is slight error is there. This will be the correct answer. Okay. Let's see the next question. 1 gram of a non-electrolyte solute dissolved in 50 gram of benzene lowered the freezing point of benzene by 0.40 Kelvin. The freezing point depression constant of benzene is this much. The molar mass of the solute is. Again, a very predictable similar question you will get in the exam. So please do solve this question and tell me the answer and let me solve also. Okay. Yes, Nagama, you have given correct answers. Mood after the class I will upload. Okay, last time I think we did not, we forgot it. Don't worry, by 7:30 you will get it. Okay, by 7:30 p.m. Okay, Sangeeta has already given me the answer for this question, 256. That is absolutely correct, Sangeeta, and very good. You have got a very good speed here. So let me just quickly discuss. W2 is how much? 1 gram. Okay, dissolved in 50 gram of benzene. So WA, or here I can write WB, and this is 50 gram of benzene. Lower the freezing point. So what is delta TF? Delta TF is 0.4 Kelvin. Okay. The freezing point depression constant of the benzene is, so we have Kf is equal to 5.12 Kelvin kilogram mole inverse. Okay. Next, the molar mass of the solute. So what will be the molar mass? Again, we can use the basic formula. All of you know delta TF is equal to Kf into WB by MB into 1000 by WA. Let's substitute it. Delta TF is 0.4, Kf is 5.12, WB is 1, MB is, we have to calculate, right, 1000 into WA is how much? 50. Okay, so if I solve this, I'll find MB value, okay, which is equal to, that you have to tell me, 256. All of you are getting, that is correct. Yes, 256 gram per mole. Okay, now let's see the next question. This is on boiling point. On dissolving 3.46 gram of non-volatile solute in 100 gram of water, the boiling point of the solution was raised to that of the pure water by 0.12 Kelvin. Calculate the molar mass of the non-volatile solute. Kb value is 0.51. Okay. Yes, Mood, all the PDFs we will upload it, do not worry. Okay. Now please solve this question. So we have 3.46 gram of non-volatile solute. WB is 3.46 gram. Okay, and we have 100 gram of water. So WA is 100 gram of water. The boiling point of the solution was raised. Delta TB is equal to 0.12 Kelvin. Okay, and calculate the molar mass of the non-volatile solute. So we have Kb value as 0.51. Okay, now let's solve it. Delta TB is equal to Kb into, what is M formula? M molality, 2000 by WA. Now if I substitute all the values, 0.12 equal to 0.51, WB is 3.46, MB into 1000 by WA is 100. Now you can solve this and tell me the value of MB, how much we will get. Yes, we have got 147 from Neon. Yes, 147.05. So Neon, you are absolutely correct. Very good. Okay, very good, dear. Yes, Sangeeta also given me the correct answer. Mood, please check the calculation. 147 is the correct answer. Nagaraj, please check your calculation. Aditya is correct here. Yeah, Madhavi, very good. All of you are doing absolutely good. Let's move to the next. Okay, now before moving to the next chapter, I'll quickly tell you what are all the important things that you must not miss from this chapter. Okay, so just put a screenshot, like take a screenshot of this slide, and before you go to the exam, make sure that you have revised all these topics. So the first one is here Henry's law. You should be knowing its statement, the formula and its applications. Next we have Raoult's law. Okay, the same statement and formula. Next we have difference between, okay, ideal and non-ideal solution, positive negative deviation, maximum and minimum boiling azeotrope, their examples, what is an azeotrope, that also you should be knowing. Next we have numericals on colligative properties, that you should be preparing. Okay, fine, let's move to the second chapter now, that is D and F block elements. Okay, some 20 questions are there. Let's solve it quickly. So according to the IUPAC transition, metals are defined as. So I have taken this question from the last session. So those students who have attempted the last session should not be doing these questions wrong. Okay, the first 10 questions are same, but the last 10 questions are different. So do stay, don't think that it is the same questions ma'am is repeating, because these questions are important. I am giving you again and again for revision. Okay, so here we have metals which have incomplete d subshell either in the neutral atom or in their ions, metals which have complete d subshell in their neutral atom only, metals which with chemical properties where transition between those of S and P characters, metals with chemical properties were transitional between P and F block elements. Yes, I have got very good answer from all the students here, 1A. So I have Neon, Sangeeta, Madhavi, Mood, BG and Nagama, all of you are correct. Yes, definitely. Aditya also, all of you are correct. A is the correct answer. Next question number 2, then let us move fast. So students, if you have any doubt, just let me know in the comment section. I will stop and explain. If you are answering all of them correctly, we'll be moving faster. Okay. So next we have the D block element not having general electronic configuration of N-1 D10 NS122. Super important question. Okay. Yes. So yes, now tell me. Okay. So can we discuss what will be this one? Which element doesn't have the same configuration or it has a different configuration? Yes, I can see. No, C is not the correct answer. Mood has given me palladium. Okay. So see, in zinc configuration is 3D10 4s2, right? Which is similar to this one or which follows this pattern. So that is why zinc is not the answer. here we have this one, and PD has a configuration of D10. Okay, it has only D10 configuration. You can check it. It has D10 configuration. Okay, yes, B is absolutely correct. Now let's see the next question. The electronic configuration of chromium is 3D5 4s1 instead of 3D4 4s2. This is due to the energy gap between the two sets 3D and 4s of orbitals is big enough to prevent the electron entering through 3D orbitals. The energy gap between the two sets, that is 3D and 4s of orbitals, is small enough to prevent the electron entering the 4s orbital. The energy gap between the two sets of orbitals is big enough to prevent the electron from entering the 4s orbital. The energy gap between the two sets of orbitals is small enough to prevent the electron from entering the 3D orbital. Okay. So first of all, let me tell you that 3D and 4s, okay, the energy gap is very small. The energy gap is not higher. That is why transition elements show such a large number of variable oxidation states. So the energy gap is small. So wherever the energy gap is big given, I can eliminate those options. So A is not the answer, bacha log. A is wrong. Okay. Now let's see. What should be the configuration? 3D4, 4s2. Right, but what is the configuration happening? 3D5 4s1. That means one electron from here, from 4s, tries to come to 3D. Right, so what will be answer? The energy gap between the two sets is small enough to prevent the electron entering the 4s orbital. Is the electron entering 4s orbital? No, the electron is entering 3D orbital. So the energy gap between the two sets of orbitals is small enough to prevent the electron entering the 3D orbital. So the electrons from 4s enters to the electrons of 3D without, because the energy gap is very small. So the correct answer here is option number D. Yes, Aditya has given me the correct answer here, that is D. Okay, let's move to the next question. Number 4, among copper, mercury, cadmium and CN, which is or are not regarded as the transition elements? Not regarded as transition elements. Copper only, mercury and cadmium only, mercury, cadmium and CN only, mercury, copper and CN only. So copper is a transition element, we all know. So wherever copper is there, we can eliminate this one. Okay. Next, mercury, cadmium and CNE, they have D10, or so I can say D10, N-1 D10 and NS2 configuration, and they have fully filled d orbital in all of their native and in the excited state. So that is why option number C here. Okay, no, B is there, but we have CN also. If you see the configuration of CN, it also has D10 fully filled configuration. So it is option number C. Okay. Let's move to the 5th question. The orbitals of the transition elements that protrude to the periphery of an orbital more than the other orbitals. So here transition elements are considered. Okay, so which orbitals of the transition elements protrude out, or protrude means are far away from the nucleus? S orbital, P orbital, D orbital or F orbital. Okay. So yes, D orbital is correct answer. All of you are giving it correct. Yes. Let's move to the next question, number C. See, it is given transition elements. Okay, for inner transition elements it will be F orbital, but for transition elements it is D orbital. Yes. Let's move to 6th one. The element having minimum volatility among the following is. Minimum volatility means they have very strong intermetallic bonding, or the metallic bonding is very, very strong. Which element is that? Let me quickly answer. Yes, tungsten is the correct answer, which has very high strong metallic bonding. Yes, Madhavi, it is B. Next, the correct statement among the following is: metals have very high enthalpy of atomization, tends to be noble in their reaction. Metals with very low enthalpy of atomizations tends to be noble in their reaction. Metals with very low enthalpy of ionizations tends to be noble in their reactions. Metals with very high enthalpy of atomizations tends to be highly reactive in their reactions. Can we guess what is the answer for this one? 7th one. Yes. Seventh one, students, quickly tell me the answer. A. Yes, neon is absolutely correct here. So when metals have very high enthalpy of atomization, they do not participate in the reactions easily. Okay, so they tend to be inert, or they behave as noble gases. Yes, A is correct. Sangeeta is correct here, and we have neon correct. Let's go to the question number 8. So we have two statement based questions. Metals are the 4D and 5D series have greater enthalpies of atomization than the corresponding elements of the 3D series, and more frequent metal-metal bonding are found in the compounds of heavy transition elements. Identify the correct statement. Statement 1 is correct and 2 is incorrect. 1 and 2 both are incorrect. Both 1 and 2 are correct. Statement 1 is correct and statement 2 is incorrect. Statement 1 is incorrect and statement 2 is correct. Yes. Which will be the answer here? Okay, metals in 3D, 4D and 5D have greater enthalpy of atomization. That is correct. And why they have greater enthalpy of atomization? Because of more frequent bonding. So both of them are correct. So that is your option number C. Yes, Neon and Sangeeta and Mood has given me correct answer. Next, question number 9. In the transition elements, a regular decrease in the atomic number or atomic radii is a result of. The regular decrease in the atomic radii is a result of filling of n-1f before nd, filling of nf before n-1d, filling of n-1f after nd, filling of nf after n-1d. Very simple question. We have n-1f orbitals fill before the d orbitals, as a result of which the poor shielding effect of f orbitals are there, the nuclear effective charge increases and the size decreases, right? So we will have 9 is A. Sangeeta, Neon, it is A. Okay, we have before n-1f orbitals are filled before n-d orbitals. Okay, okay, C is there. Fine. Okay, I'll check this question. Okay, I'll check the question and put down in the pinned comment section of this video. You can cross check it. Okay, please just give me some time. I think there's some confusion. Yeah, so n-1f orbitals fills before the n-1d orbital, right? And that is why we get what I can say, that is why the poor shielding effect of f orbitals is there, so the effective nuclear charge increases. Okay, and that is why the size will decrease. So I think, I am sure that A is the answer, but still there is some confusion. Some students are saying it is C. Okay, I'll check once more and I'll put the correct answer in the comment section. Okay, you do check it out after the lecture. Let's move to the 10th question. The element with least density. You have chromium, nickel, zinc and scandium. Least density. Which element has the least density? Yes. Okay, so students are now agreeing with A. And now let's move to the 10th question, which is having the least density. Yes, least density is scandium. Very good. As we move along the period, this density increases. Scandium has the least density. Next, the composition of chromite ore. So if you have remembered in the preparation of potassium chromate, so we have studied there, right? Potassium dichromate, chromite ore. So what is the formula of chromite ore? Chromite ore, you have FeCr2O3, FeCrO3, FeCrO4, FeCr2O4. 11A. No, Mood, you are wrong here. Okay, Sangeeta, 10th question is D. Scandium is actually the one with the lightest density. 11 is C. Nagamma is also saying. No dear, it is FeCr2O4. Okay, chromite ore. Please check the formula of chromite ore. FeCr2O4. Okay. Yes. Yes, yes. Yes, D is the correct answer. Next, we'll move to the question on the basis of uses here. So, TiO is used in pigment industry. MnO2 is used in dry battery cell. V2O5 is used in the manufacture of H2SO4. PDCl2 is used in the manufacture of polythene. So, which is the incorrect match? No issues, Neon. You can just correct it. No problem. No need to be sorry. Yes. Can you tell me the correct answer here? Which is the incorrect match? Yes, yes, Mood is correct this time. 12D. Okay, so PDCl2 is used in Waker's process. Okay, it is used in Waker's process where we convert alkenes 2 aldehydes. Okay, clear? Anup, we have done solutions chapter, and now we are in DNF block. We will be doing haloalkanes chapter also. Okay, now let's go to the next question. The radius of La3 plus is 106 picometer. Which one of the following given values will be closest to the radius of Lu3 plus? So if you remember, we have La here, and then okay, then we have certain elements that goes to the lanthanoid series. Okay, so in lanthanoid series it starts from cerium, and the last element goes to lutetium, and then we have the element which is present here. So this goes to F block, and then here the element starts from D block, right? If you see, so lanthanum is there, and they are asking me the size of lutetium, which can be the correct size. Very, very tricky question. Yes, 13C. 13C is 106 you are saying. Okay, so students, see here, as we move along the period, the size decreases, right? So if lanthanum is 106, lutetium will be less than 106. It cannot be 160, 140 or 106. It has to be less than that. So the correct answer here will be option number D. Okay, yes, Aditya has given me correct answer. It is D. Okay, not B, it is D. It will be less than that. You know, lanthanide contraction takes place, the size of the element decreases. So it will be less than 106. So it will be 85. Okay, is it clear? Yes. Now let's move to 14th question. Which of the following oxidation state is the most common among lanthanoids? What is the common oxidation state of lanthanoids? Yes, common oxidation state of lanthanoids. We have 3, 4, 2 and 5. Yes, Anand is correct, Rajni is correct. No, Rajni, it is A. Plus 3 is the common oxidation state. Yes. Next, let's move to question number 15. What is the percentage of lanthanoid metal in the mic metal? So, mic metal is an alloy of lanthanoid and iron. So, what is the composition of lanthanoid? Yes, Sangeeta, you are absolutely correct. For this question, for question number 15, tell me what is the answer. Question number 15, all of you please put the question number and tell me. Yes, neon is again correct, 95% of lanthanoid and 5% of iron. Okay, let's move to 16th question. Although plus 3 is the characteristic oxidation state for lanthanoids, but cerium also shows plus 4 oxidation state because of plus 4 oxidation state. Why does it show plus 4 oxidation state? Cerium plus 4 is less stable. Cerium plus 4 has more stable half-filled 4F7 configuration. Cerium plus 4 has a noble gas configuration of 4F0, 5D0, 6S0. Cerium plus 4 has more stable completely filled 4F14 orbital. So cerium plus 4, what is the reason? Yes, neon has given correct answer. It is option number C. If you see cerium plus 4, the configuration is like this: 4F2, 5D1 and 6S1. Okay, so when you do plus 4, these all become 0 and it gets a noble gas configuration. So that is why option number C. Yes, Anand is also correct. Let's in chemical behavior, lower members of lanthanoids is similar to metal X and higher members resembles metal Y. So metal X and Y are. So if you see lanthanoids, okay, so in which column you have beryllium, right, magnesium, then you have calcium, beryllium, magnesium, calcium, and here is something where we find lanthanum. Okay, and this side, after these elements are there, okay, after this is over, and then here you find boron, right, boron, and you have, then you have here beryllium, magnesium, calcium, and here we have aluminium. Okay, so here the properties of lanthanum, the lower metals are similar to calcium and the higher metals are similar to aluminium. Okay, so here my answer will be calcium and aluminium. Okay, 17 will be A. Sangeeta, it is A. Okay, next question number 18. Trivalent lanthanide ions to be colorless are. So which plus 3 or lanthanoid La plus 3 ions, which is colorless here? So you can easily guess this one. See, Ce plus 4 is having no unpaired electron, and lanthanum plus 3 will have no unpaired electron, so that will be colorless. So 18 will be option number B. Okay, yes, 18B is absolutely correct. Let's move to 19th question. Lanthanoids on heating with carbon produces mixtures of Ln3C, Ln2C3 and Lnc2, Ln2C, Lnc3 and Lnc, mixture of Lnc4 and Lnc, and only Lnc. Okay, so what do you think the answer? The product here produced is, yes, Anand is absolutely correct. It is option number A. Okay. Next, 20th question, actinoids to show maximum oxidation state is, which actinoid can show the maximum oxidation state? AC, NO, NP and U. Yes. 20th question, what will be the maximum oxidation state? B. No dear, it is NP, which shows +7 oxidation state, and uranium shows +6 oxidation state. Okay, it is answer is option number C here. Okay, answer is option number C. Yes. Let's move to the most important topics that you should be revising from this chapter. So the first one is why transition elements have catalytic property, why they have colored compounds, and why, the most important, why they form complex compounds, okay, why they form interstitial compounds and their properties. So these are very, very important questions. Next, preparation of KMnO4 and K2Cr2O7. Then what is lanthanide contraction, its consequences and the cause of lanthanide contraction. Also you should be learning its cause. Next we have the magnetic moment, how to calculate the formula and all you should be knowing. Then actinoids, what is actinide contraction and why it is difficult to study actinoids. That is also an important 3-marker question. Okay. Yes, so these topics you can take a screenshot and revise. Okay. Yes, Neon, definitely we will be working on Comet K as well. Okay, don't worry. Now let's move to next chapter, haloalkanes and haloarenes. Last 20 questions we have. Let's quickly buckle up guys, and we are going to solve the last 20 questions. Okay, I want full participation and 100% activeness here. Let's start. Okay, so we have dry acetone is used in Finkelstein reaction because it's volatile solvent, it contains ketone group, NaCl and NAB are formed is precipitated and favors forward reaction, Ri formed is precipitated and favors forward reaction. So what is Finkelstein reaction? You have Rx, in presence of NaI and dry acetone, we get Ri, okay, plus NaX. So this NaX, okay, it is a precipitated form. Okay, so now when you add this one, that is dry acetone, it precipitates this one and the forward reaction is carried out. So the what is my answer for here? 1C. Yes, Neon is absolutely correct. 1C is the correct answer. Okay, let's move to question number 2. Metallic fluoride that cannot be used in Schwarz reaction. So Schwarz reaction, all of you remember, Rx plus you have any metallic fluoride. Okay, you have metallic fluoride, we get Rf, right? So what is the one which will not be acting? AgF, NaF, SbF3 and Hg2F2. So yes, it is NaF2b, absolutely correct. Mood and Neon. Third question, here we have statement based question. Iodination of benzene are reversible, and iodination of benzene requires the presence of an oxidizing agent to oxidize the Hi formed. Okay, so both statement are correct, statement are incorrect, statement 1 is correct, 2 is incorrect, 1 is incorrect and 2 is correct. So yes, iodination of benzene is a reversible process, that is absolutely correct statement, and iodination of benzene requires the presence of an oxidizing agent to oxidize the Hi formed. Okay, that is also correct. And what oxidizing agent is required here? HNO3. Okay, so here we have both the statements are correct, that is option number A. Yes, yes, Mood, Aditya, Neon and Sangeeta, all of you are correct. Let's do the next question. Incorrect answer or incorrect match. Schwarz reaction COF2, Finkelstein reaction NaI, Sandmeyer's reaction CuCl2, Woods reaction Na dry ether, which is a wrong match. Schwarz reaction, metallic fluoride, correct. NaI, Finkelstein, correct. Sandmeyer reaction, CuCl2, no, we use Cu2Cl2. Okay, so this is wrong. And Woods reaction, this is also correct. So 3 only. So my answer is option number C. Yes. Neon and mood, again you are absolutely correct. Let's move to question number 5 here. A compound X with molecular formula C2H4. So we have C2H4 compound X, okay, reacts with HBr. Reacts with HBr to give compound Y, which on further reacts with Ni, okay, to give a compound Z. Identify the compound Z. So when you have C2H4 with HBr, you get C2H5Br, okay. Then when you treat it with NaI, you will get C2H5I, right. So this one will give me option number A, right. So that is iodoethane 5A. Yes, Neon and Sangeeta, both of you are correct. Aditya, it is A. Y is C, but Z is R, so that is why option number A. Let's move to question number 6. The haloarine that cannot be prepared from Sandmeyer reaction. Sandmeyer reaction is used for the preparation of chlorobenzene and bromobenzene, right? So which one cannot be prepared? This can be prepared, this can be prepared, this can be prepared. Fluorobenzene cannot be prepared. So option number C. Yes. Aditya has given correct answer C. Yes. All of you are correct here, mood and neon. Let's move to 7th question. Gaseous halo compound at room temperature. Which is a gaseous compound here? Pyrene, chlorobenzene, ethyl chloride and chloroform. So remember, if the molecular mass is less, then it will be a gaseous compound, okay. Pyrene is a very large molecule. Chlorobenzene is also large molecule. Chloroform also has 3 chlorine groups, so it is also large molecule. But ethyl chloride mass is very less. It is a small compound, so it exists in the gaseous form. Yes, 7B is absolutely correct by, yes, Anand, because of its mass, okay, less mass. If it is have less mass, okay, then it will have weak van der Waals forces, okay, weak van der Waals forces. Now if there is weak van der Waals forces, the molecular attraction is very less, then the molecule will exist in the gaseous form, okay. So that is why option number B, okay. Anand, I hope it is clear now. Okay, so moving to 8th question. The boiling points of the alkyl halides decrease in the order. You have Ri, Rbr, Rcl and Rf. Boiling point. So you know, boiling point is proportional to molar mass, okay, or mass. If mass increases, the boiling point will increase. So R is constant, you just have the halogen group, right. So I, Br, Cl and F. 8, A is absolutely correct. Iodine mass is more, so it will have more boiling point, okay. 9th question. Para-isomers of dihalobenzenes have high melting point to their ortho and meta-isomers, okay. Para will have more boiling point. The reason for that is less dipole moment of para-isomer, repulsion is less in para-isomer, symmetry of para-isomers that fits in the crystal lattice better, and unsymmetry of para-isomers that fits into the crystal lattice better. Yes, Neon has given me the correct answer, symmetry of para-isomer. So if you see, the para-isomer structure is like this. We have anything X and X, right? So it is symmetrical. So it can be packed tightly, and the symmetry nature helps in the packing of the crystals properly, and that is why the melting point increases. So option number C. Okay, Lavanya, how was the test? Please let me know how was the test, how was your exam and how much are you expecting? Next, the number of atoms bonded to the carbon in the transition state in SN2 mechanism is or are. In SN2 mechanism, transition state. So if you remember, suppose I have like this, okay, there is X, then what will happen? Suppose OH minus is attacking this one. So what will happen? A transition state is formed, where we have like this, right? You have OH, a dotted bond, and you have X. So how many bonds are there in the transition state? How many bonds are there in the transition state? Okay, so that is B5. Okay, 5 is the correct answer, that is option number B. Okay, so yes, absolutely correct. Lavanya, very good. You have got a good mark actually. That is good. 11B is correct answer. Let's move to question number 11. Now the haloalkane which reacts fast with SN2 mechanism. SN2 mechanism, what is the order? 1 degree, 2 degree and 3 degree. Last 9 questions, students. Let's put our 100% efforts here. Okay, yes. So we have methyl chloride, methyl iodide, isopropyl chloride, tert butyl bromide. So what is the answer here? What is the answer in this question? Yes, thank you Noor Jahan. Okay, so 1 degree, this is methyl chloride and methyl iodide. See, here's the confusion. Isopropyl, this is secondary, this is tertiary, this is primary, this is primary. So I can eliminate these two. But chloride and iodide, in chloride and iodide, which is a better leaving group, which bond can break easily? Methyl iodide bond can break easily as compared to methyl chloride. So that is why option number B. Yes, those are Sangeeta and Neon are absolutely correct here. Next 12th question, last 8 questions. The haloalkane which reacts fast with SN1 mechanism. What's the order of SN1 mechanism? 3 degree, 2 degree and 1 degree, right? So I have methyl chloride, that is 1 degree, methyl iodide 1 degree, this is 2 degree, this is 3 degree, same option. Which will react faster with SN1 mechanism? Quick answer, quick here. SN1 mechanism, A, no mode, please check the question, yes mode. Now, Neon, Saundarya, all of you have given correct answer, tertiary butyl bromide, okay, 212 is D answer. Next, 13th question, 13th one, select the incorrect statement among the following. Okay, enantiomers possess identical physical properties. Enantiomers only differ with respect to the rotation of plane polarized light. Enantiomers are stereoisomers relating each other with non-superimposable mirror images. Enantiomers are optically inactive. Yes, what is the correct answer here? Yes, Lavanya, Aditya, Neon all have given the correct answer. It is option number D. Okay. Yes. Next question number 14. The alkyl halide to produce a racemic mixture in SN1 reaction. So now to produce a racemic mixture, be very sure that the compound must be chiral. Okay, the compound must be a chiral compound. Now you see isopropyl chloride. Isopropyl chloride, is it a chiral compound? Is it having 4 different groups? No, right? So this is not there. Tertiary butyl bromide. Tertiary butyl bromide is having this structure. Is it a chiral compound? Is it having 4 different groups? No. So this is also incorrect. 2-chlorobutane. 2-chlorobutane. Is it a chiral compound? Yes, ma'am. Here I have methyl group, here I have ethyl group, here I have chlorine group and here I have hydrogen group. 4 different groups are attached. So that is why this will show the racemic mixture. Okay. And methyl iodide is also not a chiral compound. Okay. Yes, 14C only Neon has given me correct answer. Aditya has given, Lavanya has also given. Okay. Next 15th question. The major product formed when 2-bromopentane reacts with alcoholic KOH. 2-bromopentane, okay, reacts with alcoholic KOH. So remember about Sedzeff rule. What does it say? We have pent 1 ENE, pent 2 ENE, pent 2 OL and pent 1 OL. Yes, so if I have H here, I have H here. Here I will get an alkene, here also I will get alkene. According to Sedzeff rule, more substituted alkene is the major product. So this alkene will be the major product, that is pent 2 ENE, option number B. Yes, see, pent 2, no dear, it is alcoholic KOH. If it is given aqueous KOH, okay, then Br will be replaced with OH, you will get pent 2 OL. But it is alcoholic OH, it is an elimination reaction, okay. Okay, fine. Now let's move to question number, Lavanya has given option number B. Yes, Lavanya, you are correct. Now let's move to question number 16. Chlorine containing antibiotic produced by microorganisms which is very effective for the treatment of typhoid fever. Which is used for the treatment of typhoid fever? Yes, typhoid fever, we have option number C. No, the correct answer for is option number A. Anita has given me correct answer. It is chloramphenicol. Okay, chloramphenicol is used for the treatment of typhoid fever. Okay. Yes, Neon has given correct answer. Let's move to 17th question. The halogen containing compound used as anesthetic during the surgery, anesthetic drugs. Yes, what is used as an anesthetic? Chloramphenicol, thyroxine, chloroquine and halothane. Quick answer here for question number, yes, Mood has given me correct answer. D, halothane is the correct answer, where we will get that is used as an anesthetic during surgery. Last three questions dear. 1,1-dichloroethane is also called as 1,1-dichloroethane. 1,1-dichloroethane. So this is a geminal dihalide, right? So how do we name the geminal dihalides? Ethylidene chloride, ethane chloride, ethylene dichloride or pyrene. So it is called as ethylidene chloride. That is option number A here. Okay. Yes, Neon, Mood, Prithvi, Lavanya, all of you are absolutely correct. Last question, second last question. The total number of structural isomers possible for the compound having molecular formula C5H11Br. 4, 5, 8 and 6. Take your time for 1 minute and solve this. Take your time and solve this. 19th one. Yes, Neon has already given me the answer. Mood has also given the answer. C5H11Br. Okay, let's try this one. I have C5 first. I'll do 5. Okay, I'll put one bromine here. That is one isomer. I'll put one more Br here. That is another isomer. I can put a bromine here. Okay, that is another isomer. Okay, I have got 3 isomers here. Now let's calculate for this one. That is 1, 2, 3, 4 and you have a 5 here. So here bromine will come, or here you put bromine, you will have one compound. Okay, next we have bromine here. Okay, that is another isomer. Next you have bromine here, that is another isomer. And then if you have bromine here, that is another isomer, right? So we got 1, 2, 3, 4, 5, 6, 7 and let me draw a chain of like this, and here I have a bromine. So that is my 8th isomer, that is option number C. Okay. Yes, Aditya, you can see all the structures that I have drawn, all the structures I have already done, you can check it, you will get C. Okay. Yes. Next, question number 20. Which among the following has a chiral carbon? Means it will have all the 4 carbon groups, all the 4 bonds will be different. Okay. 19th is option number C dear. 8 isomers we will get. Okay. Here 2-chloropropane. If I draw 2-chloropropane, do I have all the 4 groups different? No ma'am. So this is not a chiral compound. 3-chloropentane. If I draw 3-chloropentane, this side ethyl group, this side also ethyl group. I don't have 4 different groups attached. So this is not also chiral ma'am. 2-chlorobutane. 2-chlorobutane. Yes ma'am, this side I have methyl group, this side I have ethyl group, this side chlorine group and this side hydrogen group. 4 different groups are attached. So this is a chiral compound, definitely option number C. Yes, all of you have given C correct here. Yes. Okay, so that is the end of the question session, but here I have something very important that you must revise before going to the exam. Okay, first SN1 and SN2 mechanism, 5 marker, pakka question will come from here. Do revise it again and again. Next you have name reactions. Okay, one reasoning questions, why haloarenes are less reactive than haloalkanes. This is also a 3 marker question. Do revise that. Then name reactions, Schwartz reaction, Finkelstein reaction, Woods reaction, Woods-Frittig reaction, Friedel-Crafts reaction. Okay, that is also correct. All these name reactions you should know the definition as well as example. Then some definitions of racemic mixture, enantiomers, what is a chiral carbon, what is inversion, what is retention, those all things also you should revise. Lastly, nomenclature, very important, and isomerism. Okay, so please practice these questions. These are definitely going to come in your exam. and do not miss anything from here. Okay, so and now if you want to, if you have already studied, you just want to revise the questions, you can watch this video where I have given all the important questions of all the 3 chapters. And if you have want to do a quick revision, here I have given the most important question list, and here we have done DNF block one shot. Those students have doubt in this chapter, you can go through this. Okay, so that's all in this class, students, and I hope this session was helpful. I didn't waste much of your time. We have completed within 1 hour 10 minutes. Okay, so I hope the session was helpful for all of you, and do let me know how was your exam once it is over. Please put down in the comment section of these videos, these questions, these revision sessions were helpful for you or not. Okay, thank you so much and all the very best. And if you have any doubt in any question, please leave in the comment section. I will address to all of them. Okay, thank you for watching and all the very best. Bye bye, take care.